All right, so this is where we're going to write quadratic equations in intercept form. And by intercept form, we mean x-intercepts. So it's important that you know x-intercepts can also be called zeros or roots or solutions. Those words are synonyms, okay? So all of those words can be kind of used interchangeably. So it's important that you understand all four of those words and that you understand we're talking about x-intercepts when we say intercept form. Our x-intercepts are always going to be P and Q in this equation, y equals A times x minus P times x minus Q. So how do we solve for a quadratic equation in intercept form? You have to identify your zeros, your p-value and your q-value. And then you have to go ahead and decide, okay, what is my third point going to be? And of course, we're usually just going to give you that. And you're going to need to label those values. So we kind of have up here at the top of your note sheet an example problem. Okay, now you can read through that if you want to. It's going to be there at any time. Go ahead and print that off from the computer, or you can ask me for a hard copy. Either is fine. But let's do just a couple of example problems. So our first step, we are always going to identify P and Q, and P and Q are always your x-intercepts. So we first were given two x-intercepts here as ordered pairs. Our p-value is going to be 1. And our Q value is going to be -7. Now, how do we know both of those points are x-intercepts if I didn't tell you they were x-intercepts? Well, the thing that's special about every single x-intercept is it always has a y value of 0. We're not going to be using those zeros in our equation. We just use those zeros to help identify, hey, those values right there, they're x-intercepts. That's P, that's Q. Also, P and Q can be switched. You can label the 1Q and you can label the -7P if you wanted to. Now, we also have to be given any other third point. It doesn't matter if it's a vertex. It doesn't matter if it's a y-intercept. It can be any other random point. And we just happen to be given a y-intercept in this point, in this problem. But we're going to label the other point, our third value, or our third point. We're going to label it x and y. So we have identified P and Q and X and Y. So our next step, I'm going to go ahead and write down our intercept form of the equation, y equals A times X minus P times X minus Q. And we need to sub in all of those values that we just identified. So our Y value is -42. We do not know our A value. But when we sub in our x value, it happens to be 0, and our p value is 1. So that's going to be x minus 1. Because this is a minus right here and right here, because those are both minus, the symbol that we use, whether it be a plus or a minus, is always going to change. See up here how our p value was a +1? When we sub it in, it's going to be x minus 1. Also, when we substitute in our x minus q, our x value that we're using is still, oh, I forgot to change this one out. Sorry. Instead of writing x, we want to write our x value. What was our x value? 0. Okay, our x minus q, that's going to be 0 minus a -7, which really means +7. Okay, so step 1, label P, Q, X, Y. Step 2, sub in your values. Step 3, we're going to solve for A. So inside your parentheses, PEMDAS, that's what we're simplifying first. 0 minus 1 gives us -1. 0 plus 7 gives us a +7. And we're just bringing down everything else, right? -42 equals A times -1 times 7. It's important that you do not drop your parentheses. All right, two parentheses side by side. That just means we are multiplying. So this is -42 equals A times -1 times 7 gives us -7. Now, I don't want a times negative 7. I just want a. So we've got to divide both sides of our equation by negative 7. And that gives us our a value of positive 6. That was step 3. That's the most math that you're going to have to do for this, okay? The most number crunching that you're going to have to do, right? So we solved for a. Step 4 says we are going to rewrite our equation in intercept form using our a value, our p value, and our q value. Only those 3 items. So in black, we have our intercept form. Y equals, we're subbing in a, which was positive 6, times x minus p becomes x minus 1, times x minus q becomes x plus 7. That's your first example. All right, your next example on the back of your note sheet, it says write an equation in intercept form given the following. You are given roots, x equals negative 2 and x equals negative 5. Roots are the same thing as x-intercepts. So go ahead and label them P and Q. They're not given to you as an ordered pair in this instance. We just tell you, hey, these are your roots, P and Q. Your parabola, your quadratic, is also going to go through the point 136. So that's our x value and that's our y value. So I'm going to go ahead and start by writing my equation in intercept form. And again, that's the form that I would want to use because I was given the x-intercepts to begin with. So y equals a times x minus p times x minus q. All right, so let's sub in our values. Our y value is 36. It's going to equal some a value times x minus p times x minus q. What are we subbing in for x minus p? Our x value is 1, and we are going to subtract p. Well, minus a negative 2 really means plus 2. That's why when you sub in your p value, it looks like the sign changes. X minus q. Our x value is still 1, minus a negative 5 means plus 5. All right, step 1, label everything. Step 2, sub in your 4 values. Step 3, we're going to solve for a. 1 plus 2, that gives us 3. 1 plus 5, that gives us 6. So we have 36 equals a times 3 times 6. Well, 3 times 6 is 18. So 36 equals a times 18. Divide both sides by 18. And our a value is equal to 2. So now all we need to do is take the general form of this equation and sub in our 3 values. We're subbing in a, p, and q. So y equals our a value of 2 times x plus 2, because remember our value, the sign changes when you sub it into your equation, times x plus 5. There you go. All right, last example. It says write equation in intercept form given the following. So what information are you given? If I look at this parabola, I see that I'm not only given my x-intercepts, I'm also given the vertex. So if you are allowed to choose which form you want to write, you could have used vertex form if you wanted to. But we're going to go ahead and practice intercept form since that's what we're working on today. So our first x-intercept, our first p value is negative 5, and our second x-intercept or our q value is positive 1. Now this vertex, because I'm using intercept form, I am not going to label it h and k. We don't have an h and k in intercept form. Remember, the third point can be any point that we want it to be. So in this instance, I'm going to label this x, comma, y. All right, so we've identified, and our formula is y equals a times x minus p times x minus q. Let's sub in our values. Our y value is negative 4 equals some a value that we don't know times x minus p. So our x value is negative 2. And when I subtract my p value of negative 5, minus a negative 5 really means plus 5. And then when I have x minus q, it's negative 2 minus 1. So that's step 2. Step 3, we need to solve for a. So PEMDAS, we need to simplify inside the parentheses first. Negative 2 plus 5 is 3, keeping my parentheses. Negative 2 minus 1 gives me negative 3, keeping my parentheses. So we have negative 4 equals a times 3 times negative 3. Let's multiply. 3 times negative 3. That gives me negative 4 equals a times negative 9. Solve for a. We're going to divide both sides by negative 9. And that gives us our a value equal to positive 4 over 9. It does not simplify any more than that. So let's rewrite our equation using a, p, and q. Y equals 4/9 times x minus a negative 5, which really means plus 5, times x minus q, so x minus 1. Now, if you really want to have a good time and that was super easy for you, go ahead and come in and see me about this critical thinking problem at the bottom of your notes. If you have any questions, feel free to come in. As always, love you, mean it.